For this class, we're going to look at section 3, and there's only one lesson in this section. We're looking at 2D relative velocity. So from earlier in the week, we have finished up one-dimensional velocity, combining vectors. We learned how to combine two vector quantities when they both act along the same plane of motion. In other words, whether they're both acting horizontal or vertical. So just an example of what we had looked at, a boat heads 20 kilometers per hour north relative to a river, while the river flows at 15 kilometers per hour south relative to the Earth. What's the boat's velocity relative to the Earth? So here, there's only one plane of motion. So we have a river here, and just to give a direction, this is north. And we have a boat that's moving. Let's draw on our boat. And the boat is moving north, and we're told it's moving 20 kilometers per hour. Meanwhile, the river is flowing south, so it's going upstream. The river is flowing 15 kilometers per hour south. So then what's the velocity of the boat relative to the river? Well, again, one of the ways we can work this out is in our head. And what we had said, if you look at this, if it's trying to head north at 20 kilometers per hour, but the river is moving south at 15, well, the river's moving against the boat. So the most the boat can head forward then is at 5 kilometers per hour. Now, if you want to look at vector addition, sorry, we won't do vector addition, but look at the math behind it. So if we went to add these, the river's moving 15 kilometers per hour south. So you would need the directions to be the same. So we'll say 20 kilometers per hour north. We won't change that one. But this one has to get changed to north. And if you're going to change it to north, then it's no longer a positive 15, it's a negative 15. And after you do the addition, it's 5 kilometers per hour north. Now, if we want to use the notation we looked at earlier the week, so I'll just move this out of the way. You write down what you're given. So the velocity of the boat with respect to the river is 20 kilometers per hour north. The velocity of the river with respect to the Earth, so the river's moving 15 kilometers per hour south, or I'd already changed that here to negative 15 kilometers per hour north. So I'd already done that. And you can see that over here where I changed that. So that's where the negative 15 came from. And what we have to find, the velocity of the boat with respect to the Earth. So if we look at our equation, we would have set this up. The velocity of the boat with respect to the Earth, and what you are asked to do is take the B and the E and space them out. So the B here goes in front and the E goes behind. Now if you want a different color for that, maybe make it easier. There. And oops, sorry guys. There you are. So the letter that's in front, put it there. The letter that's behind, put it there. And then fill in the information you know. So the only other object involved here, you include the boat, the Earth. You see the boat, Earth. The only object in this question is the river. So you just fill the area in. And write in the values you know. So 20 kilometers per hour north, negative 15 kilometers per hour north. And so the velocity of the boat with respect to the Earth is 5 kilometers per hour north. So that's in one plane of motion. We're talking north-south, one direction. Or, yeah, one plane. So now we're going to include two directions. So we're working on finding the net or resultant vector. Right here. Of an object whose two velocities combine and affect each other. The resultant vectors would now be at right angles to each other. So everything we do here is going to be to involve right angles. Keep in mind Pythagoras' theorem is going to come through in these questions. So examples of where this happens. A boat's moving across a river and a current downstream is pushing it off course. So if you look at the little cartoon over here, we have a boat that's going to move across the river, but yet the river is going to try and move it downstream. So here you're setting at your right angle. And we want to find how does the boat end up across the river, or where does it end up. An airplane is flying in a crosswind. So you see it here, the nose of the airplane is not lined up with the runway. And what's happening is that as the plane's coming into land, wind is pushing it off course. So the pilot will have to adjust. So to combine vectors and find the net or resultant, we can use one of the two methods. We can use the scale diagram method or a mathematical model. And both would work. Remember, if you're going to use a scale diagram, you're going to need a scale and draw a diagram. So this is going to take more time usually. And you'll need a ruler. Okay, so for example 1, you have an object that's moving 4 meters per second north while it's getting, say, let's use a river example. That'll probably be easier since we just spoke about it. So let's say north is in this direction, which would mean east is in that direction. So the boat is trying to head north across the river at 4 meters per second. Meanwhile, the river is moving downstream at 3 meters per second. So the boat's not going to head straight across. It's going to push it downstream. So find the resultant velocity when vector 1, that's this one, and we label them 1 and 2, are combined. Well, here's your vector 1, and you add in your second vector, and remember the rule. We had said the tail of the second, so here's the second vector, goes to head of the first, and that's right here. So this is now our resultant vector. So we need to know the velocity of the resultant vector, or we may also refer to that as the net vector. And remember, the arrowheads are important because they're vectors. And for a vector, you also have to know the angle. So if we just fill in our numbers that we have here, we know that this is 4.0, this is 3, and if they combine at right angles, you can use Pythagorean theorem to find the resultant velocity. So the velocity net is going to equal v1 squared plus v2 squared. And v1 is 4.0, we have to square that. And v2 is 3. So you have 16 plus 9. And 16 plus 9 is 25. So in order to get the resultant, or net, you have to take the square root. So to get rid of the square, you take the square root of this number. So you have to take square root 25. So your answer is going to be 5.0 meters per second. Now you may be tempted to stop there, and that's a common mistake, but you also need to have the direction. So you have to go back here and find theta. Remember, they have a right triangle, so use trigonometry. If you're standing here at this point, this is opposite, and this is adjacent. So trig function, if you want to remember SOHCAHTOA, the only one that we can use is tan. So tan of theta is your opposite, which is 3, over adjacent, which is 4, and to get theta, it's the inverse tan, 3 over 4. And guys, I suggest you try this because it's a poor time to figure out that your calculator is not working right or you're not sure how to put the numbers in is on a test, because I can't tell you. So if on your calculator you try second function 10 and then 3 divided by 4, the angle works out to 36.86, or we're going to round it to two significant digits, or 37 degrees. So your answer here now, take note of how you're doing this. The direction you're going is north, so you're heading north, but the river's pushing you off course by 37 degrees, and the direction it's pushing you is east. So that's your net result. Okay, time for you folks to have a little bit of fun. I want you to try this one. So I'd ask that the video be paused and you guys have an opportunity to try it, and then when you come back I'll have it worked out for you. So a river has a current of 3 meters per second south. A boat can travel 4 meters per second in still water. Find the velocity of the boat relative to the earth if it heads directly from east bank to the west bank. Alright, so hopefully you guys got it figured out. So if we look here now, river has a current of 3 meters per second south. So let's consider this direction here, south, and the river's moving at 3 meters per second. So the boat is trying to head across the river here. Now, so the boat can travel 4 meters per second in still water. So that's the speed it can travel. And if the boat's trying to move across and the river's pushing it downstream, well, we know that the boat should end up somewhere over here. Now that may be a little hard to see, so let me just change the color there. So if the boat's heading across here, but the river's moving it down, well, the boat should end up somewhere over here. So you may want to do your own little diagram on this. So you have your first vector here, and that will be the boat traveling across, and now it's getting pushed down the bank. And this will be the resultant vector. When you draw on your resultant vector or net vector, do it dashed, put your arrowheads in, now work out your equation. And if you notice, made this one a little easier on you guys, the answer should work out the same as the last question. So if you set it up right, if you look back to the last question, the workings are already done for you there. Again, it was 4 and 3. So this is the equation you should have came up with, and this is the vector that you should have gotten for your resultant. So I don't need to repeat it. You guys have already seen it, and you can look back, and I'll also post these notes online for you to see there. So I'll make a note here. Same workings. As example 1. Alright. Okay, so next one now. An airplane flies due east. Its speed in still air, referred to as airspeed, I'll just highlight that for you, is 80 meters per second. The wind is blowing to the south at 30 meters per second. Find the velocity of the plane relative to the ground speed. So that's the same as saying the Earth. So we have two vectors. So we have V1, and that is 80 meters per second. So it's flying east. And V2, the wind is blowing it south, and that's moving at 30 meters per second, and that's south. So again, do your vector addition here. So theta. So we need to find the velocity of the plane with respect to the ground. So velocity of the plane with respect to the ground. And in order to do that, we have to use Pythagorean theorem, and I'm going to stop here now and let you folks work it out. Okay, so let's say you've done everything you need to. That's worked out. So you should have V1 squared plus V2 squared. If you wanted to, you could say the plane with respect to the air. And here, you could say the velocity of the, what was the other one? The wind with respect to the, let me fix that there, guys. And it would be the air with respect to the ground. There we are. So again, first letter in both. First letter here becomes the first letter there, and the second letter becomes the second letter there. And the only other object involved was the wind or the air, if you, whichever way you want to look at it. So you have 80 meters per second east, so that has to get squared, plus 30 meters per second south. And 80 squared is 6,400. Now I'm going to drop the units there because they're just going to get in the way. And 30 squared should be 900. Adding both together, you end up with 7,300. Now remember, this is squared, so in order to solve it, you need to take the square root. So I'll do the square root of 7,300. Which is 85. Meters per second. And I'm going to go back to my question here. We had two significant digits, 3 there, so two significant digits there, 3 here. So you go with your lowest number of significant digits, which is 2. So I'll only use 2 in my answer. So you figure out this part here, that the plane is actually moving at 85 meters per second with respect to the ground. What you need to figure out now is what is the vector, what is the direction it's moving in. We had the magnitude, had the size of the velocity, but you also need the direction now. And you have, again, if you look here across, you have the opposite and the adjacent. So the only trig function used is tan. Your opposite is 30. Your adjacent is 80. So theta is the inverse tan 30 over 80. And I'll expect to see these workings done. Don't rush through the question, because if you make a mistake, then you cannot get part marks. And that works out to 21 degrees. Not exact, but when you do the rounding, it will work out 21. So your answer is 85 meters per second. And you are heading, okay, your primary direction is here. So if I just highlight that for you. So this is your main direction right here, going that way. And that direction is east. So you're heading east and you're blown off course by the wind, and you're blown off course by 21 degrees, and it's taking you south. So there you are. Alright guys, for the next 3 questions, example 4, 5 and 6, I want you to do these in the remainder of class time. If you don't get them done, then they are homework, and I will be checking it when I return, and we will correct them in class.